Hello everyone, welcome back to our program. I'm Mr. Amoyavi, one of your grade 12 advanced maths teachers. In our last lesson, we talked about the derivatives of exponential logarithmic functions. In today's lesson, we'll talk about integration and specifically indefinite integrals, as you can see. All right, so what is integration? Integration is basically the opposite of differentiation, the process of differentiation, right? So if given a function, a derived function like what we have here, dy over dx is equal to 2x plus 2. This derivative can be obtained from the series of functions. As you can see, if I have to differentiate this function, I get the same derivative. Or if I have to differentiate the second function, I get the same, or the third one. All right, so the rule for integration is basically this one. If given a derivative function or a gradient function, dy over dx is equal to ax raised to the power of n, then the integral is going to be basically this function here. Y is equal to ax raised to the power of n plus 1 divided by n plus 1 plus the constant of integration. Now, as you can see, the rule is very basic and it's easy to follow. If I have a function and then I have that exponent, what I will basically do is I will add 1 to the power and divide the expression itself by the new power that I got. So, right, so this is the rule for integration, or how to find an indefinite integral of a derived function. Right, so let's take a look at some examples. Before that, the general notation you may have seen somewhere is this. For expressing an indefinite integral, if I have this symbol, then you must know, or you must read it as an indefinite integral, right? So if I have to write something like this, ax raised to the power of n, and this function is integrated with respect to x, dx basically means with respect to x. So if I have to integrate this function, then the primitive or the indefinite integral will be equal to, it's going to be just the same thing that we have written, ax raised to the power of n plus 1 divided by the new power, which is n plus 1, plus the constant of integration. C is called the constant of integration. Right, so let's take a look at some examples here. A. If I have to integrate this function, let's say 2x squared plus, let's say 3, with respect to x. Then just following this rule here, I will write y is equal to 2x squared plus 1 for this term, and then divide the expression by the new power, which is 2 plus 1, plus 3. For 3, we know it's a constant number, but it's a term that has got x raised to the power of 0. So we just simply follow the same rule and we add 1 to this power. And then the new power is 0 plus 1 again. And then don't forget your constant of integration at the end. Right, so if we are to simplify this expression, we get 2x raised to the power of 3 divided by 3 plus 3x raised to the power of 1, but we don't normally write 1, the power of 1, so we just write 3x. Divided by 1 will be just that number, so it will be plus the constant of integration. This expression is called the indefinite integral of this function. Now let's take a look at the second example. If I have 3x cubed plus 2x, and we are to integrate this function with respect to x, then our indefinite integral will be 3x cubed plus 1, and we divide the expression by the new power, 3 plus 1, plus we also have to apply the same rule here. That's 2x raised to the power of 1 plus 1 divided by the new power, which is 1 plus 1, plus the constant of integration. Right? Therefore, the indefinite integral of this function now will be 3x raised to the power of 4 divided by 4 plus 2x raised to the power of 2 divided by 2 plus c. Okay, finally we can do the simplification if required. Right, so if you look at this one, 2 and 2 can cancel out and you are left with x squared. Okay. Therefore, finally, your final answer will be 3x raised to the power of 4 divided by 4. 2 cancels out, so it will be x squared plus the constant of integration. So this is your indefinite, this expression here is your indefinite integral of this function here. All right, since we have mentioned that integration is the opposite of differentiation, we can apply differentiation to this function to see if we are going to end up with this expression. Okay. So we can quickly do that proof. Right, if I have to find the derivative of this function, I have to bring the 4 in front. So that would be 4 multiplied by 3 over 4x to the power of 4. And then we minus 1 from this one. And then plus, bring the 2 in front. And then we minus 1 from the power. Okay, so that is the process of finding the derivative of a function like this. Right, so we will have 4 cancels out. We are left with 3 x raised to the power of 4 take away 1 is 3 plus 2 take away 1 is 1. So we will have this function. Right, so as you can see, we ended up with the same expression here. So this concludes that the process of differentiation or integration is the process of differentiation. So you can prove your answer by taking the derivative of the function that we have obtained here. Okay. Right, so this brings us to the end of our lesson. And what we have basically learned is the integration is the reverse or the opposite of differentiation. So using this formula here, given a function like this one, and using this formula, we can reverse the process and write the indefinite integral, which is the function from which the derivative function is obtained. Thank you, everyone. In our next lesson, we'll talk about definite integrals.